G'day and welcome to another one of my videos. Today we're going to have a look at finding the area of a circle. So let's get straight into it. So here we have a circle, and what we could do is we could actually place squares inside that circle and try and count them for its area. So if we do that, we can try and count all of those squares, but you'll notice that we've got some part squares which are hard to put together to make whole squares. So we could try and count all of these squares, and we've got little bits and so on left over. And what we'd actually end up with is an estimate of the particular area of the square. So someone else counting them might come up with a slightly different answer. So I think we've got an area of approximately 34 square units with this particular circle. So when we put all our little bits together and so on, then I think we've got about 34 square units. Okay, so let's try and find the area of a circle. I'm actually going to show you where the formula comes from. We could divide this particular circle up into small sectors. So sectors are just like pieces of pizza. And the smaller that we can make those, the more accurate we will actually be. So what I'm going to do is cut this up into sectors. And what we've got is we've got two halves. So I'm going to have a top half and a bottom half. And we're going to actually unfold those halves so that you can see the sectors spread apart. So we've got a top sector there, and I've spread them apart, and we've got our bottom one there, and I've spread those apart. And what we're actually going to do is to mesh those together, and what we've basically got is some sort of primitive, very rough looking parallelogram. So if I actually made these sectors smaller, so if I cut it up into more than 16 pieces, this would actually flatten out along here and along here as well. And we've got this rough parallelogram, and with that parallelogram we've got a base and we've also got a height. So the base, the length of this base here, remember we split this circle up into two halves, so we've got a top half and a bottom half, and the circumference of the circle are those curved parts there, but that's for the whole circle. We cut it up into two halves. Now remember, twinkle twinkle little star, circumference equals 2 pi r. So the circumference of the full circle is 2 pi r. So if we only want half of that, that's just pi r. Half of 2 is 1. So we've got that is just pi r. So let's put that in. And then our height here, so we're going from here up to here, is just the radius of the circle. So the height of the particular parallelogram is just the radius of the circle, so we put that in. Now we already know from a previous video on how to find the area of a parallelogram, and that's just base times height. So remember, our base is the length across here, which is pi r, and our height is r. So let's put those together, bit of algebra, and we get that our area is pi r squared. So what we've got here is the area of a circle is pi times the radius squared. So in summary, when we've got a circle and we know its radius, then we can find the area of that circle by just using the formula area equals pi times the radius squared. Just be careful that you don't get it confused with circumference, and that's why I try and teach my students that twinkle twinkle little star, circumference equals 2 pi r. If you want area instead, area equals pi r squared. So that's just a way of remembering which formula is which. So let's do a couple of examples. So we've got a circle here and its radius is 8 millimeters. So just like I do with other questions, if there's a rule, let's write down the rule first. So area is pi r squared. Let's substitute in what we know. Our radius is 8 millimeters. And let's work that out on our calculator, remembering your pi button, so you don't have to remember that pi is 3.1415926, etc. And then a question says correct to 2 decimal places, so you need to round that off. So there's our decimal point, 1, 2 places. Check our next digit, it's a small digit, so it doesn't influence the 6. So our area is approximately 201.06 millimeters squared. For our second example, We're given the diameter, but still we want to find the area, so let's write down the rule, but we don't know the radius this time. So what we're going to do is cross out that 15 so that we don't use the wrong number, because that's diameter, and actually use the radius, which in this case is 7.5 kilometers. So a half of 15 is 7.5. And then we substitute that in, use our calculator, and again round that off to get 176.711. In fact, it should be kilometers squared. So I'll fix that later. And then what we now need to do is I could make this harder by giving you a semicircle. So once you get your answer, you would just halve it, or you could get a quadrant where you just find a quarter of it, or even just a sector. So it's the angle over 360 times the answer. So I hope you found that useful. What you now need to do is to practice and practice and practice some more. And the more that you do that, the easier it will become and you'll remember so much more. So thanks for watching.